Hi and welcome back to another LeetCode problem. I'm currently browsing through easy problems to practice the interview process. And now we're dealing with LeetCode 3492 maximum containers on a ship. It's the first time that I see this problem, and I'm going to try to solve this one shot, but interview style, where I focus on communications, etc. Right, so let's see what we are dealing with here. So we are given a positive integer n representing an n by n cargo deck on a ship. Each cell on the deck can hold one container with weight of exactly W. So we're getting n and we're getting W. However, the total weight of all containers, if loaded onto the deck, must not exceed the ship's maximum weight capacity, max weight. So every cell on the grid can carry W, but the total sum of all cells cannot exceed max weight, right? Each cell on deck can hold one container with weight of exactly W. Okay, so only one container, nice. Return the maximum number of containers that can be loaded onto the ship. And the weight. So is weight the container? I guess we should assume that we have containers of weight W, and then we have to see, how many containers we add before we exceed max weight. So, but yeah, let's look at the constraints. So what are we working with? Well, at least we'll have one, at least we can load one container. The weight is at least one, and the max weight is also at least one. We don't care about the upper bounds, by the way, for runtime and space complexity analysis sake. Okay, let's look at the example. So here we have two cells. The weight of a container is, max weight is 3, and the max weight is 15. So the cell has, the grid has, the deck has 4 cells, right? 2 by 2. And each container weighs 3. The total weight of loaded containers is 12. So that's 4 times 3, that's 12, which does not exceed the limit. So the output is 4 containers. Next example, so we have a 3 by 3 deck, so 9 cells. The weight is 5, but max weight is 20, so we can only load 4 containers. And that's what we'll put on. Okay, cool. So I think we can come up with the O of 1 time and space solution, because we can immediately determine how many containers we can load depending on the weight. So for 1, we can divide max weight by the weight. That returns us the maximum containers. Like we do an integer division, max weight divided by weight. That returns us the maximum containers. And then we just have to limit that by the square of n. And that's it. So yeah, that's short one. So O of 1 time and space. And what we return is we return max weight integer divided by W. And then we have to return the minimum between that and n squared. Not mistaken. Okay, test cases passed. Let's submit this. Okay, well, I'm sorry you took the time to watch this video. This was shorter than I expected.